So before we start, I have a question. Who here has contributed to the OpenStack code base? Okay. Well, first of all, deep respect to all those who do. A few words about myself. I'm Anton, or as people call me, Weiss. I work at Automato. We're a boutique consulting and services team company in the field of DevOps and software delivery enablement. What I've been doing for the last decade is building continuous integration and continuous delivery systems for different software projects. And this is exactly what we're going to be looking at today. How the continuous integration for OpenStack is built. Let me start by saying that I'm not even sure I'm the right person to be talking about this. Okay, I haven't contributed a single byte of code to the OpenStack CI infrastructure. The full credit for building this thing goes to the OpenStack infrastructure team. Some of the names I'll be mentioning along the presentation. But a couple of years ago, a friend of mine told me, you're dealing with continuous integration with Jenkins, you should go and see how OpenStack is built, because their continuous integration infrastructure is something special. So I went and started learning and started asking questions, and I think it is very, very advanced, the OpenStack CI infrastructure. As someone put it, probably the most insane CI infrastructure that has ever existed. And it's good to know how it's built, what its components are, because they're all open source. They can all be reused in different software projects that we're building. Okay, so let's start. OpenStack is big. One of the largest open source projects out there today. Here are some statistics from a couple of months ago. Almost 3,000. No. Okay. A lot of commits. Almost 6,000 developers. 54 project teams. And freaking 585 Git repos. Okay, this includes the core OpenStack projects and the StackForge projects, all the accompanying and assisting projects around OpenStack that has been built and developed in the last years. So it's a lot of code. It's a complex system. There are a lot of commits flowing in every day, every hour, every minute. So in order to be able to keep this stable, to keep the trunk of this stable, to keep testing this and make sure that things are not broken on a daily or hourly basis, you need a very advanced CI infrastructure, as we already said. And that's what we'll be looking at. Okay, so here's a diagram of the OpenStack CI system. This is the whole almost the whole map of what a commit has to travel in order to get into the OpenStack trunk. We'll be looking at each of the components separately. And this whole thing is developed and managed by the mighty OpenStack infrastructure team. Okay, one thing that isn't on the diagram that we just saw is this whole thing is, of course, managed correctly as infrastructure as code. So, in fact, if you want to go and build your own OpenStack CI at your organization, you're perfectly able to. There is documentation, and there are Puppet and Ansible manifests and playbooks, respectively. So the CI infrastructure for OpenStack, the great thing about it is, as the project itself, the same way it has been developing and improving over the years. So the story is they started using Puppet to manage the CI infrastructure nodes, but at some point they gave up the Puppet master. So now there's a node that's called Puppet master, but it's only historically called so, because what it now holds are Ansible playbooks that are triggering Puppet apply on the actual nodes. Okay, these are two, Ansible and Puppet, two invisible hands managing the CI infrastructure nodes. Well, it all starts with the code, and the code goes to Git. I won't be talking too much about Git. Everybody knows in the last decade it became de facto standard for open source version control, and actually gaining more and more market share for large enterprise commercial projects. I guess there are reasons for that. It's being served to OpenStack developers by the use of Seagate, which is another open source project providing web serving for Git. And the changes are submitted by another tool also managed by the OpenStack infra team, which is called Git Review, a Python utility, which allows submitting code changes to Gerrit. Okay, who here has heard about Gerrit? Yeah, quite a lot. It's a known system. It has been developed for the Google, another big open source project, Google Android development for the code review. It manages Git repositories inside, and it provides us with an ability to define code review and approval rules, a matrix of what kind of checks and what level of approval code change has to pass in order to be merged to the trunk. And it enables us collaborating with human and non-human gatekeepers, human being the pure developers who can review our code, and non-human being the continuous integration system that we're looking at. Now, what Gerrit does is it emits an event stream. So each time a change set is committed to Gerrit, or someone comments on a change in Gerrit, or someone approves a code change in Gerrit, Zuul listens to the event stream and gets the respective events. And then what it does, it defines the gating process. It defines the checks that the code change has to pass. Zuul is an open source project developed by the OpenStack infra team, okay? Specifically by the great James Blair. You should just go search it on YouTube if you haven't, and listen to him talking about Zuul. This is nowhere near a deep dive into Zuul. It's a great system. The nice thing to know that this is an open source system. It's very flexible. And what it does, it allows us to have different kinds of checks, okay, different kinds of pipelines in Zuul language. What happens is, whenever a patch set is submitted to Gerrit, this triggers a check pipeline in Zuul, which just checks our code for style, for if unit tests are running correctly. This is totally independent of other changes. But the actual killer app for Zuul is its ability to, well, I'll start with why it's good. You know, yesterday I went to Jerusalem to the Light Festival. Ever heard about it? Great thing, great show. If you have kids, or even if you don't, just go and see it. But it was a disaster to get there, okay? Traffic jams all along the way. Took me 2.5 hours to get from Tel Aviv to Jerusalem to park the car. What happens is, I already said, we have a lot of changes coming into all the OpenStack projects all the time. And to test these changes takes a long time. The whole integration suite takes something like 2 hours. So what if we had to wait 2 hours to integrate each of the changes? We'd have traffic jams all along the way. What Zuul allows us to do is whenever each change comes in, it merges that change with the previous approved and verified change, and then sends it for testing. And what this allows us to do is to test the changes parallelly. Well, no, there was one thing I didn't put right. It merges it against the previously committed change. It doesn't have to be approved and verified, okay? So it assumes it will be approved and verified, so it merges it again that. If the previous change fails in the test, then it cancels the test for all the subsequent changes and marks them for retesting. So the best case scenario, if all the checks pass, we run the test parallelly, and then we can merge all the changes that are in the queue. And the worst case scenario, we still have to merge them and test them serially if everything fails. What happens in real life is much closer to the best case scenario, which allows us to test a lot of changes in parallel. Zuul doesn't do the actual job execution. Okay, it just defines the rules. He's the guy who says, okay, so we've got the documents for all those guys waiting in line. This is where they have to go to test their documents. And it dispatches the verification process to Jenkins. By the way, do you remember who Zuul is, who this ugly guy is? Right, yeah, he's the mystical gatekeeper from the monster from the Ghostbusters. I certainly like this charming form best. Okay, so Zuul sends the testing jobs, dispatches the testing jobs to Gerrit. Okay, Gerrit is another open source application. You know, they say that to be a good manager, you have to know how to delegate. So Gerrit allows us to do exactly that. It allows us, our application, to delegate or to outsource some work to other applications, processes, machines that are better suited to do that work. And what it does is it sends jobs to Jenkins, masters and slaves. And we'll see in a minute why that is needed. Because the natural question would be, why shouldn't Zuul just send the jobs straight to Jenkins? And I said Jenkins. Okay. I think probably some of you here do use Jenkins. How many? Quite a lot. Yeah, I have a special place in my heart for Jenkins too. I've been working with Jenkins for quite a long time. So it's a great, very flexible, open source continuous integration server. What it does, it schedules and executes jobs specifically for OpenStack. These are testing jobs, and records execution results. It does that by dispatching the job execution to slaves. There is a Jenkins master, and it has the execution slaves, and it sends them the jobs and monitors what happens to those jobs and records the results. Now, the Jenkins used for OpenStack is not the nice, cute little Jenkins user-friendly GUI that some of us know. It's a freaking monster. Okay, from Jenkins Gerrit plugin documentation, it says it has more than 20,000 jobs and sometimes more than 900 slaves, okay, which is certainly beyond anything that regular Jenkins use case is meant for, okay? So what that brought into picture is the need for more Jenkins masters. Now, Jenkins, you can install as many Jenkins masters as you want, but the problem is, in the way Jenkins works, you can't share context between different Jenkins masters. Now, this is made available by the Jenkins Gerrit plugin, also written by the OpenStack infrastructure team, specifically by James Blair and Kay Doe. There is also a lecture on YouTube about the plugin. So go find that and listen to that. What Gearman plugin allows Zuul to do is to send jobs to a lot of Jenkins masters and a lot of Jenkins slaves. So what happens is Gearman manages the job queue, and Jenkins does only the actual job of monitoring the jobs and recording the results. Okay, and this allows to scale it to a lot of Jenkins masters who have shared Jenkins slaves. Now, did I say Jenkins for OpenStack is a monster? Did I say 20,000 plus jobs? That's something nobody would be able to manage manually. Okay, so in the same way that we have infrastructure as code allowing us to manage thousands of servers, something that we wouldn't be able to do if we had to manage them manually. In the same way, OpenStack infrastructure team has developed a Jenkins Job Builder, which is nothing else than Jenkins jobs as code. Okay, this is a project that allows us to actually define Jenkins jobs in simple YAML. It provides us with some building blocks and abstractions, defaults, macros, templates. This is a small example of how a job can be defined. So if you find that your own Jenkins infrastructure is growing too big and you're feeling that it's becoming hard to manage it by hand, go look that up. It's a great project as well. Can be used with no connection to the OpenStack itself. And I also said more than 900 slave nodes. So some of these nodes are static nodes used for static code checking and style checking and things like that. But a lot of these nodes have to be dynamic, because what they do is they run test integration suites, integration test suites. Excuse me. And what that means is these slaves become stale and contaminated, and we need clean slaves to run the jobs on. The correct solution would be each time I need to run a new test, I'll bring up a new clean node and run the test on that, which is a good solution, but it takes time to bring up new nodes, and we don't want traffic jams. For that reason, the OpenStack infra team developed Nodepool, which is a project that makes sure that we always have available nodes for OpenStack infrastructure tests, integration tests. Okay, what Nodepool does, it provisions nodes on the HP and Rackspace clouds that are provided for the OpenStack projects respectively by HP and Rackspace. And it listens to another Jenkins plugin developed by the OpenStack infrastructure team, which is Jenkins ZeroMQ Publisher plugin. And whenever a new testing node is being used, it knows that that node is not available anymore, and it goes and brings up a new clean node so that the subsequent testing suite, subsequent change that comes, will have a new node to be tested upon. And whenever a test is finished, it also gets an event from Jenkins and goes and removes that node from the cloud. Now, how the tests are run. So I said unit tests, I said style checks. Some of the components can probably be tested by themselves, but we're building a cloud here, and we have all the different projects, Nova, Neutron, Keystone, you name it, and they all have to play nicely together. This is being made available, the test of this is being made available by the DevStack Gate. Have you used DevStack? Okay, I don't know about you, but DevStack is a nice OpenStack project that allows you to actually go download the whole of OpenStack and run it on your own computer. For me, it was the gateway into OpenStack. I wanted to see how this thing called OpenStack works, so that's what I used. I went and downloaded DevStack, and I had OpenStack running on my laptop. And that's what allows the OpenStack CI infrastructure to run integration tests. The nodes are brought up with DevStack installation and being tested on that, with the help of Tempest, which is the OpenStack integration test suite. And of course, it wouldn't be a modern day continuous integration infrastructure if we didn't have some log storage, indexing, and search infrastructure. And this is, of course, based on Logstash. All Jenkins jobs logs are indexed and stored to Logstash. The pushing of the logs is also handled by Gearman. And there's Elasticsearch that helps analyze and test, analyze the test results. So the wrap up of what we looked at today. We have Git, we have Gerrit, allowing us to do code reviews and send things for testing. We have Zuul, who defines what happens with each of the changes. We have Gearman, which allows Zuul to send the testing jobs to more than one Jenkins master, with Jenkins masters sharing a lot of slaves. We have Jenkins Job Builder, which builds the jobs based on YAML file definitions. We have the Jenkins itself, and we have DevStack, which allows us to install OpenStack on a single VM node and run integration tests upon that. We have Nodepool that takes care of bringing up those nodes where DevStack gets installed. And we have Logstash storing the logs. And these are only nine out of 32 projects and tools managed by the mighty OpenStack infrastructure team. So there are others which I haven't mentioned. I didn't have the time to. Certainly, there's much more to learn about that. I invite you to go and learn more about this. And as I already said, this is all open source. We can all use it for our own benefit. And here are some references. Thank you very much. Questions? If I remember correctly, right now there are 3 Jenkins masters in the OpenStack CI, though I may be not up to date on this information. And well, the jobs are being regenerated all the time from what's defined in the infrastructure repository by the Jenkins Job Builder. So you don't need to manage the jobs manually. They're all being regenerated on all of the masters. And the masters, as I already said, they don't manage their own queue because the queue is being managed by Gearman. So they're quite dumb, those Jenkins masters. They don't have the usual brain that you expect a Jenkins master to have. They simply, send the jobs, read the output, store the results. Thank you very much.